Hey everybody, the purpose of this video is to walk you through E1 from the normal distribution homework, from our homework sheet. And I think once you get E1, you'll probably end up getting the gist of the E2 through E5. But it seems like this problem's just weird enough to warrant more than just an answer. I told you the answer was 9%, but maybe some starters to get you kind of going on the problem will be warranted here. So the question is, we got a shower head in the Ramada Inn in Bishop, California that's 68 inches above the floor. And my question is, if men have an average height of 70 inches with a standard deviation of 3 inches, I pulled those numbers from U.S. Department of Health and Human Services. If those figures are accurate and the shower head's at 68 inches, if I've defined comfortably sitting under a shower head as having at least 2 inches between the top of your head and the shower head, what percentage of men fit comfortably under the shower? So you know it's a bell curve problem, a normal distribution problem, because you have to get onto this curve. But the kicker is, where on this curve are you? And this is where you have to get between a general normal and a standard normal type of problem. So here's how we look at it. The standard normal is centered at 0, and that's fantastic if you're talking about the standard normal distribution, but here you're talking about the general normal distribution, which involves being centered on 70 inches. So 0 on the standard normal corresponds to 70 inches in the general normal. So far, so good. With a standard deviation of 3 inches, that means we have to go up and down 3 inches from that to get one standard deviation of adult male heights. And then up and down, sorry, that's my alarm telling me to put the chickens away, but I can't do that while I'm here. 73 to 76 inches, and then 67 down to 64 inches. So now, I think we've got enough range to start this problem. We now have a range of 2 standard deviations, which spans a foot, and 1 standard deviation spans 6 inches. The question starts by asking, what percentage of men fit comfortably under the shower head? We know the shower head is fixed at 68 inches is right about here, actually. So, and I made a definition. I said, by definition, if you have at least 2 inches of space between the top of your head and that shower head, at least 2 inches of space, you're comfortable, okay? So, if 68 is where the shower head is, that means you can't be any more than 66 inches tall. Because any more than that, you don't have enough of the 2-inch space. Like I'm 71.5 inches somewhere in there. So the shower head for me is like right here in my face. So 66, if I translate that up to the graph, is going to have a z-score. These are the folks that fit comfortably. A 64-inch person is going to fit fine. A 62-inch person, a 60-inch person, a 65.5-inch person is going to fit fine. But as soon as you exceed 66, these folks are not going to fit. So you can see right away that we're going to have a very small percentage of people, somewhere between 1 and 2 standard deviations below average. So we can calculate that momentarily. But that's the z-score you need to find. And I'll get you started on that z-score. To convert this bad boy to a z-score, to normalize it, it's fairly straightforward. You use the exact same conversion formula we've been using in class. You take your raw score, subtract off the average, and then divide by the standard deviation, which was 3 inches. And then you end up with -4/3. That's your z-score. That's the marker on the standard normal curve that tells you, okay, that separates the area that will fit from the area, or that separates the percentage that will fit from the percentage that won't. So that guy right there is -4/3. So -4/3 of a standard deviation below. And so you can kind of get a ballpark of how big this is going to be, because you know that 68% of everybody fits between -1 and 1. So that's about 68%. If that's 68%, that puts 16% here and 16% down here. So adding that 68% to this 16% here, you end up with what, 84%. 84% won't fit from here to here, and then there's still a little bit of chunk from here to here that won't fit. So that gives you a ballpark. You know you're inconveniencing more than 84% of people. So using the normal now, and this is the part you can figure out yourself. You know it's a forwards problem because you're looking for an area. you know the right bound of the shade left is -4/3, and that's all you're going to need to to crunch to figure out what the overall percentage is. So I hope that gets you started. The big thing I think that throws people off is you have to take the 2 inches off in the beginning. And I think having the 2 inches off in the beginning is a little bit goofy, but you just have to realize that if it's a 68, you can't be any more than 66 to be comfortable. Hope that helps.